How's it going, guys? Welcome to Leetcode 2466. Happy New Year, guys. Welcome to Leetcode 2466, Count Ways to Build Good Strings. In this video, I'm going to be explaining both approaches on how to solve this problem. This is a dynamic programming problem, right? It says, given the integers 0, 1, low and high, we can construct a string by starting with an empty string, and then at each step we perform either of the following. We can either append 0 0 times or append 1 1 times. And then it says this can be performed any number of times. A good string is one that is constructed and the length lies between low and high inclusive, these two variables, right? Return the number of different good strings that can be constructed. Since the answer is large, return it modulo 10 power 9 plus 7, right? So in this question, this is a dynamic programming question because for each, if we have, let's say on the right side, we don't have a string at all. For every step, we can either take 0 0 times. So let's say 0 is like 3 and 1 is like 3 times. You can either take 3 zeros or 3 ones. So I can do this. I can start like this, or I can start like this. And then when I do this, I can either go zeros or I can go actually ones again, right? So there's always two decisions you can do for every step of the way till you construct a string that lies between low and high, right, inclusively. So a way to, I'm going to be starting by solving this from the top-down approach, where the top-down approach there's two approaches in dynamic programming. There's bottom-up, and then there's top-down, right? Top-down approach is generally recursive. Bottom-up is generally iterative. So in the first one, which is the top-down approach, what I do is we have a character count, right? We don't need to actually construct the string. We don't need constructing the string. We just need the character count. We just need to maintain it, right? So there's a few base cases we have to take care of. For example, if the character count is greater than high, we return 0 because this is an invalid string because it's greater than the boundaries, right? If the character count, we'll leave this for now. This is the memoization part. And then we'll start off by saying the total. The total resembles the total number of strings that can be constructed. Like, this is the answer. So if the character count is in the range of low and high, if it's in the desired range, then that means it's a good string. So what I do is I'm going to append 1 to the total, increment the total by 1, because it actually lies in the required string, right? When I do that, we have to keep going, right? Because let's say we just hit the character count is the same as low, right? So we just hit low, but we need to keep going till we reach high, because all of these are good strings we need to still calculate, right? So then I can either do two things. I can either add zeros to it, or I can either add ones to it, to the current count. And that's what I do. I just append either zeros or either ones, right? And then at the end, we use memoization, where we have a hash map of repeated visits, like double work we've done before, right? Because, for example, if we have a character count of 5, 5 can be reached either by starting as, like, let's say we started off as like 5 zeros, right? And then we went recursively this direction. And then after we finished, we went recursively with starting with 5 ones, right? So when you're on number 5, it's going to be the same answer regardless. So that's why we use here memoization to keep count of, like, this. Basically, this hash map, basically the key means for every character count, right? If the character count is like at 5, from 5, what's the most strings I can make that lie between low and high, right? That's basically it. And then we return dp character count. So that runs, that works. And now I'm going to show you another method, which is the bottom-up approach, where it's iterative more than, like, I'm going to tell you how to translate these, like a structure like this, into an iterative one. So basically, we start off having an array of dp, right? It's going to be the same thing. It's an array initialized with zeros, right? What's the maximum character count I can have is probably high, right? I can't exceed high. If I exceed high, it's all zeros. It's all useless anyways, right? So I initialize the array with high plus 1. I don't even need the plus 1, by the way. I just did that because why not? I don't think I need the +1. No, I don't. Okay, so then you look at this. You look at this, and then you try to find what is so-called the recurrence relation. What is the recurrence relation? That means, what do I need? So to compute the index I'm currently on, do I need data from the previous indexes or from the forward, like the not yet to come indexes, right? So we can deduct this from here, because since I owe to get the current total, I need to go forward. I need to go character count +1s and +0s. I need to find the later ones so I can have my result. That means we can go from right to left. We can iterate from right to left, because we need to calculate the right ones first, since they are dependent. The left ones are dependent on the right ones, right? So after knowing the recurrence relation here, I'm gonna check. First of all, I initialize dp that lies between low and high. They have initial values of 1, because as I said, the I represents the maximum number of strings for this character count. Each I resembles a character count, right? And the value of it resembles the maximum number of strings it can carry, right? That lie between low and high. So from low to high, the initial value is 1, because they can all pass, right? These character counts are all valid as strings. And then we go from right to left, right? We go from right to left, and then we check if I add zeros to the current character count, which is the I. If I add zeros to it, if it is less than high, I can actually I can actually like the DP of it. So the DP resembles the maximum number of strings. We're gonna add to that the maximum number of strings for I +0, which is pre-computed because we go right to left. Same for the ones, right? We add the ones farther away with DP I +1 to DP. That means we compute the current index based on indexes to the right of it, right? And then we just return dp of 0, and then we obviously mod it because it says that in the question. So yeah, that's been it. The time complexity is actually O of character count, which is for dynamic programming. What is character count? Probably something along the lines of worst case could be like O of n. Yeah, it's O of n. Thanks for watching this video, and see you soon.